Hello, good morning, or good evening, or afternoon, wherever you are. Welcome back to the channel. Today is day 7, where we shall be concluding the actual introduction to Kubernetes. I am very just glad about the continuous, can I call it a continuous consistency? If there is such, oh my God, I need to stop a tab. Okay, let's continue. The other tab was also playing, but let's continue. So yeah, I'm saying I'm very happy for myself and also for you who has been learning along with me. Yeah, being consistent pays off. So let's look at workloads today. So it says workloads, okay? They say the goal of this is to understand pods, okay? The smallest deployable compute object in Kubernetes and the higher level abstractions that help you run them. We've been learning about pods again and again, okay, over the past 6 days. And yeah, today we're concluding a week. It's interesting how just being consistent for a week and giving an hour a day. Okay, we've just been learning for 1 hour every morning. And yeah, it's been great so far. And I can tell you, my level of understanding of Kubernetes is very different from what it was at the beginning. So yeah, let's see what they're talking about in this documentation today. So here they say a workload is an application running on Kubernetes. They're saying whether your workload is a single component or several that work together on Kubernetes, you run it inside a set of pods. Okay, so I need to read this again just to make sure I've understood it. They're saying whether your workload is a single component or several that work together on Kubernetes, you run it inside a set of pods. So ideally, a workload is an application running. Okay, so whether they're saying whether our application is a single component, whether we have only one application running, or more than one or two or more running applications which are working together. To run these workloads, all these applications which are called workloads, they have to run inside a set of pods. So that's what I understand, that an application which is running on Kubernetes runs inside a set of pods. And like we saw yesterday, pods have runtimes, okay, which are responsible for running the actual container. Let's move on. Down here, they're saying in Kubernetes, a pod represents a set of running containers on your cluster. Okay, a pod represents a set of running containers on your cluster. And if you hover over this, they're trying to represent, to explain what a container is. And it says a lightweight and portable executable image that contains software and its dependencies. Yeah, this is what ideally an image is. And we discussed this over and over again over the past 30 days. In the past, I mean. So yeah, a lightweight and portable executable image that contains software and all its dependencies. Now I'll move on to the next paragraph. So like I've always been telling you, so a pod, okay, so actually your application is running inside what? A container, okay? And like what we said yesterday, the container runtime is responsible for running that application, okay? And that container, okay, is inside the pod, okay? So they're saying Kubernetes pods have a defined lifecycle, okay? And they're saying, for example, let me select all this. For example, once a pod is running in your cluster, then a critical fault on the node where that pod is running means all the pods on that node fail, okay? For example, once a pod is running in your cluster, Okay, once a pod is running in your cluster, then a critical fault on the node where that pod is running means that all the pods on that node fail. Yeah, this makes sense because a node is simply a machine, okay? If you look at this definition, they're saying a node is a worker machine in Kubernetes. So if, just in the normal sense, imagine you had maybe a fast API application running on your computer, and then your computer crashes, okay? That application would collapse immediately, okay? Islam, welcome to the stream. Where are you watching from? Is your first name pronounced as Shafiq Cole? Shafiq Cole? Correct me, but welcome to the stream and thank you for learning with me. So let's go ahead with this, okay? Now, this I think should make sense to you. I understand it, okay? Like I said, the normal, if in case you had maybe like a JavaScript application, direct application running on your machine, and your machine got an issue, okay? Definitely, it would what? Kill, if your machine got an issue and maybe ran out of memory or it was destroyed by a mechanical injury, you'd expect your application to also stop working. And the node in this case is like your machine, okay? And the pod is, think of it as like your React application now running, okay? A container for your application to run, a box, kind of. So the say Kubernetes treats that level of failure as final. You would need to create a new pod to recover, even if the node later becomes healthy. Okay. So if anything happened to our node, okay, the machine, that means that's a failure. Okay. It's final and it needs a recreation of a new pod. Okay. So let's move on to the next paragraph. They're saying, however, to make life considerably easier, you don't need to manage each pod directly. Okay. Instead, you can use workload resources that manage a set of pods on your behalf. This is good. Okay. So there are resources that help us to manage the pods. Okay. You're saying these resources configure controllers that make sure the right number of the right kind of pod are running to match the state you specified. They're saying these resources configure controllers that make sure the right number of the right kind of pod are running to match the state you desired. Okay, you specify them in. So if you look at this, we have seen this definition again and again. Okay, but it doesn't have to read it one more time because it will simply help us to reinforce our understanding of what it's all about. Okay, because we've read about controllers before. You're saying a control loop that watches the shared state of the cluster through the API server and makes changes attempting to move the current state towards the desired state, okay? Watches the shared state of our cluster and using the API server makes changes attempting to move the current state to the desired state. So it is important for us to actually keep on reading this repetitively, okay, until we grasp it, okay? So the API servers or the controllers make sure that we have the right kind of pods, okay, every time. So they're saying Kubernetes provides several built-in workload resources, okay? Now, what are those workload resources, okay? The first one we have here, the deployment and replica set, okay? They're saying replacing the legacy resource replication controller. And they're saying this is a duplicated API that manages a replicated application. Okay, so they have the deployment and replica set. I think we have seen the deployment in the past, if you remember. Okay, and they're saying, let me select all this. They're saying a deployment is a good fit for managing a stateless application workload on your cluster. where any pod in the deployment is interchangeable and can be replaced if needed. A deployment is a good fit for managing a stateless application workload on your cluster, where any pod in the deployment is interchangeable and can be replaced if needed. That's a good thing. All right, so they're saying, next statement says, StatefulSet lets you run one or more related pods that do track state somehow. For example, if your workload records data persistently, you can run a stateful set that matches each pod with a persistent volume. Your code running in the pods for that stateful set can replicate data to the other pods in the same stateful set to improve overall resilience. Okay, so to understand, I want to do this again. It says stateful set lets you run one or more related pods that do track state somehow. Okay, so think about pods working together. Okay, and they're saying if our workload records data persistently, we can run a stateful set that matches each pod with a persistent volume. Okay, simply think of it as storing data. Okay, outside the container. Okay, that's what I understand volumes to be. And it's saying our code running in the pods for that stateful state can replicate data to the other pods in the same stateful set to improve overall resilience. Then, okay, so these are the built-in workload resources, the deployment and replicability of stateful set. You already no need to cram this, okay? Because I'm sure ahead we shall keep on meeting these terms, and in the long run it will stick. Okay, they're saying DaemonSet. DaemonSet defines pods that provide facilities that are local to the nodes. Okay, every time you add a node to your cluster that matches the specification in a DaemonSet, the control plane schedules a pod for that DaemonSet onto a new node. And I think we know what a control plane is. Okay, every time we add a node to our cluster that matches the specification in a DaemonSet, the control plane schedules a pod for that DaemonSet on a new node. You're saying each pod in a DaemonSet performs a job similar to a system daemon on a classic Unix or POSIX server. You're saying a DaemonSet might be fundamental to the operation of your cluster, such as a plugin to run cluster networking. It might help you to manage the node. It could provide optional behavior that enhances the container platform you are running. So that's what a DaemonSet is. Okay, let's go to the other one. They're saying job and cron job should be things that we are aware about. Okay, they're saying job and cron job provide different ways to define tasks that run to completion and then stop. You can use a job to define a task that runs to completion just once. And they're saying you can use a cron job to run the same job multiple times according to a schedule. Okay, those who are used to Linux and who have done some backend development in the past must be used to this. Okay, so yeah, job and cron job simply are ways to define tasks that run to completion. Okay, and then stop. Okay, so like you're saying, a job defines a task that runs to completion once. Okay, then a cron job runs multiple times. You can say for a cron job, you can say run every day at midnight. Okay, every day. But a job you can say runs only, like for example, if you set a job for running at midnight, it will run at midnight today once. But a cron job would run at midnight every day. Okay. Yeah, and I think these are very popular cron jobs. Let's go on. They're saying in a wider Kubernetes system, you can find third-party workload resources that provide additional behaviors. Using a custom resource definition, you can add in a third-party workload resource if you want a specific behavior that's not part of Kubernetes core. For example, if you wanted to run a group of pods for your application but stop, it's saying, for example, if you wanted to run a group of pods for your application but stop work unless all the pods are available, perhaps for some high throughput distributed task, then you can implement or install an extension that does provide that feature. All right. So yeah, this is it, but we're not going to follow this. What they're saying, what's next? I'm going to follow the original table of contents. Okay. So now in the next videos, I think we shall now go to the actual stuff. Okay, building upon it. So yeah, this is what a workload is. I don't see anything hard or complicated about this. Okay, this would mark the end to studying the theory. Okay, about Kubernetes, or I mean not the theory, but the end to the introduction. Next up would be the practical, and yeah, see you soon when I resume back the practical learning of Kubernetes. Bye for now.